So, before Thanksgiving, we talked about congruent triangles. And what does it mean for two triangles to be congruent? And same side lengths and same angle lengths, right? Or angle measures. Okay? So, you take one and put it on top of the other, right? So, if two triangles are congruent, then all of their corresponding parts are congruent, right? Do you remember what we called that? With some letters.
There's S. There's S. C.
Remember what that stands for? Corresponding. Corresponding parts of congruent triangles are congruent. Say that with me. Corresponding parts of congruent triangles are congruent. Which means all the corresponding and all the corresponding sides are congruent. Okay? So, we learned about CPCTC. We know what that is. Okay? We talked about triangles. Now, we also talked about some ways to prove triangles congruent. Now, obviously, you can show all three angles congruent and all three sides congruent. That's a lot of things. We talked about two different ways before Thanksgiving. What were the two ways that we talked about?
Angle, side, side.
We didn't talk about angle, side, angle.
Side, side,
side, angle, side, where the angle has to be sandwiched in between the two sides. Okay? Today, we're talking about ASA and AAS. Okay? So the first one is the angle, side, angle congruence criteria. And if two angles of one triangle and the included side are congruent to two angles and the included side of another triangle, then the two triangles are congruent. Okay? So you can see here that these two triangles, MLN and SRT, that we've got a pair of angles here with a single arc. Okay? We have a pair of sides and another pair of angles with a double arc. And you see how FN and ST are sandwiched between those two angles. That establishes angle, side, angle. Angle, side, angle. The side has to be sandwiched in between the two angles. And that establishes congruency. Okay? So, we're going to talk about some ways that we can prove triangles congruent. Now, we're going to have to kind of clean the cobwebs out and go back to some of the stuff we learned back in chapters 1 and 2. Okay? 3 possibly. No, not 3. But definitely 1 and 2. Alright, so we want to look at what we're given. Okay? And we're given that CT bisects angle BCR and angle BPR. And we want to prove that triangle BCP is equal to triangle RCP. So basically, these two triangles are separated by diagonal. Now, we're told that CP bisects BCR and BPR. This right here is BCR. What does that tell me? As CP bisects. Both angles created by the bisector are congruent, right? So these two right here are congruent, correct? Okay. CP also bisects BPR, which is this angle. What does that tell us? Both of those angles are going to be congruent to each other, right? Okay. So these two are congruent to each other. Okay. So when you work through proofs, you want to first ask yourself, what can be determined from the given? Okay. And we got the bisector equals congruent angles, right? Okay. So we're going to state that here that we know that these two angles are congruent. Those two are congruent. You also want to say, okay, what can you get from the picture? Now, when I say that, you want to look for, do they share anything? You want to look for vertical angles. You want to look for linear pairs. And those are some things that you want to look for. Okay? So, what can you determine from the picture? Okay, CP is shared by both triangles. So it's congruent to itself. Okay? So if that's the case, is this enough information to prove the triangle's congruent? By what? Angle, side, angle. Alright, so now we want to put it in a proof. Okay? So we're given that's given to me. From that, that's their bisector, it creates congruent angles. So we want to say that angle BCP is congruent to what? RCP, angle RCP. And we want to say that angle BEC is congruent to angle RBC. Alright, so those pairs of angles are congruent. What's my reason for that? Definition of angle bisector. Alright, so we have now stated a pair of angles, right? That's all we can get from the given. So then we went to the picture and we said that they shared CP. How would I state that? CP. Now would you switch it in this case? Look, you've got a single and a double. CP would be congruent to CP in this case. Okay, so you wouldn't switch them around. Let me show you why. Okay, this is the reflexive properties. You would switch it around if it looked like that. Okay, because CP in this triangle corresponds with PC in this triangle. So CP at the bottom corresponds with PC at the top. So we go from one arc to two arcs, one arc to two arcs. You see what I'm saying? Okay? And the reason that we don't is because we say that these two are congruent and those two are congruent. So again, you want to go from one arc to two arc, one arc to two arc. Okay? So that one would be switched. Does that make sense? No, there's not a rule that says that. You want to put the corresponding parts in the right order. Okay. All right. So we have stated a pair of angles and a side, and the side is in between the two angles, right? Even though we didn't state it in that order, that's okay. So now we can say that triangle BCP is congruent to triangle RCP. What would my reason be? ASA. So, as long as you have those three things stated before you state this, that's okay. So, that's not to say that it doesn't matter the order of anything. We'll talk more about that in a minute, but these two could have been switched. Okay, the second and third step could have been switched to what's been wrong. Okay? Alright. A technician installs cables from a cell phone tower to the ground. To pass inspection, both cables must be the same length. Does this installation meet the cable length requirement? Okay, so basically they're saying, are these two cables the same length? Yes, how do we know? Well, you know that these two cables are 52. Yes. These two are both 90, right? And they share this actual tower, correct? What does this establish? Angle, side, angle, right? And so if these two triangles are congruent, then these cables are also going to be congruent by what? Okay. The triangles are congruent by angle, side, angle, but these cables are congruent by CPCTC. Corresponding parts of congruent triangles are congruent. Okay, so we can say that the two triangles are congruent by ASA. Therefore, the cables are congruent by CPCT. There's a difference between what ASA does and what CPCT does. You do not understand the difference. The ASA proves these two triangles congruent. Once you know the two triangles are congruent, then all of the other corresponding parts are congruent by CPCT. What does CPCT stand for again? Corresponding parts of congruent triangles are congruent. Okay. to each other?
Yes.
Yes, by what? Angle, side, angle, angle, side, angle, angle, side, angle. I would guess. Side A, F, A. Okay. What about JKL, which is the first one, and PQR? Yeah, why not? This one's side angle, but in this one, the side is not sandwiched in between the angles. Okay, so this one would be no in triangle PQR, the congruent side is not included between the congruent angles. Make sure you look closely. And don't just look at the first one and say, oh, yeah, that's angle side angle. You gotta look at the second one and make sure it matches up, okay? Alright, here's another proof. Okay, VR is perpendicular to RS. I'm gonna go ahead and write it down. So VR is perpendicular to RS. UT is perpendicular to SU. And RS is congruent to US. Okay, so that's my given. What does it mean for VR to be perpendicular to RS? Okay, yes, indirectly. If they're perpendicular, they create a right angle, right? Okay, so that's a right angle. And then UT and SU are perpendicular, which means they create a right angle, right? So I can say that those two angles are right angles. And so what do we know about right angles, other than the fact that both measure 90 degrees? Because they measure 90 degrees, you can look at it like that, but we learned this theorem that says all right angles are congruent, right? Okay, so you can bypass the 90-degree thing. It's true, but you don't have to state it, okay? Because we already have a theorem that says all right angles are congruent. Okay, so we have a pair of congruent angles there, right? And then it also tells us that RS and US are congruent, right? Can we get, that's all we can get from the given. Can we get anything else from the picture? Yes. Okay, our vertical angles are also going to be congruent, okay? Now, I'm trying to prove that VR and TU are congruent. What am I going to have to do before I can state that? The triangles are congruent, is that what you said? Yeah, show that the triangles are congruent. So are the triangles congruent? Yes, by what? ASA, right? And so if the triangles are congruent, then all the parts are congruent. Yes, by what? Okay. Alright, so we state our given, and from these first two parts, we said that there were right angles, right? So we can say angle R and angle U are right angles. And what's my reason for that? That's going to be the second step. Definition of perpendicular. Okay, definition of perpendicular lines. Lines that intersect and form a right angle. Okay? Alright. Okay, so because they're both right angles, I can now say that angle R is congruent to angle U. And that would be what? Just said it a while ago. All right angles are congruent. Okay, so do you see the hierarchy here? You see that you have perpendicular lines. From that, you got right angles. Because they're both right angles, you can say that they're congruent. Okay, you see how that works? That would have to be in that order for the proof. Okay? Alright, so that takes care of the right angles. Then we were given the sides congruent, and then we noticed that our vertical angles were congruent, right? Okay, so that would be our next step. And we would say that angle, if I said RSB, how would I have to say the other one? UST. Angle UST are congruent, and that is by vertical angles theorem. Okay, so let's see. we have an angle here, we have a side here, and we have another angle. Is that enough to prove the triangle's congruent? Yes. So I can say that triangle RSB is congruent to, how would I say the other one? UST by ASA. Okay, so the triangles are congruent. Now I can say that VR is congruent to TU by TC. Corresponding parts of congruent triangles are congruent. Okay? Questions on what I did there? See how I told you got to go back and clean out some of those cobwebs. Remember we talked about all this earlier on. Okay, this is going to come back. Okay? Alright. Now, the next way to prove triangles congruent is the AAS congruence criterion. Okay? If two angles and a non-included side of one triangle are congruent to two angles and a non-included side of another triangle, then the two triangles are congruent. Okay? Alright, so notice here that you've got an angle, and then this side is not included between the two angles. It's a non-included. Okay? Angle side, angle side. Okay? Alright, so here's another little proof that we're going to do. Angle A is congruent to angle D. Okay? And C is the midpoint of EB. Where can I get from that? C is the midpoint of EB. EC and BC are congruent. Okay? Definition of midpoint. Alright? And what else? C. But that's all we can get from the given. Angle BC. And BC. Yes, why? Vertical angles, right? Okay. So is that enough for the triangles? Yes, by AAS. Okay. So we've got part of this for us here. We got the given stated. Then we had to state that EC is congruent to BC. What was that reason again? Definition of midpoint. Okay, and then we stated what? Yeah, but we can't say C congruent to C. Right, there's four angles at C. So we would have to say angle BCA is congruent to BCD, angle BCD, and that's, what reason is that? Vertical angles parent. Okay, so that takes care of an angle, a side, and another angle was already given to us. So this triangle ABC is going to be congruent to triangle DEC by what? AS, right? Because the side is not in between the angles, yes? Correct? Okay. Now this one's pretty easy. I got most of them for you, so I'm fill in the blanks. But it's based, it's based on the same type of idea. Prove that FH is congruent to JL. Now, they tell us that GH and KL are congruent. They tell us that GFH and KJL are congruent. And FGH and JKL are the marked, right? So, we want to prove that FH is congruent to JL, right? Before we can do that, we have to prove the triangle's congruent. Is there enough information to prove the triangle's congruent? Yes, by what? AAS. Okay? And so the triangles are congruent, so that the other parts are congruent by what? What is it? Corresponding parts of congruent triangles are congruent. Okay, good. Then you might have some questions. What additional information is needed to prove these two triangles congruent by ASA? So, we've got a pair of angles and a pair of sides. What else do we have to prove in order for the triangles to be congruent? Okay? We would have to prove angle C congruent to angle E, right? Okay? pair of ASA, right? Okay. What if I wanted to prove a congruent by AAS? Okay, angle C would have to be congruent to angle F, and that would take care of the AAS. Okay. Alright, last little bit here. State whether each pair of triangles is congruent by SAS, SSS, or ASA. This first one. Are those two congruent? ASA. Okay, what about the second person? SSS. Okay. Angle side, right? But you gotta look at both of them. Angle side, we're good. Okay, what about this one? Okay, I've got side, angle, side here, but what do I have here? Do they match? No. So this one is not possible. That's why I said it's important to look at both triangles. We established SAS here, right? But the two sides of the angle weren't in jive. Okay, so that's not possible. Any questions? So far, we know SSS, we know SAS, ASA, and AAS. Tomorrow, we're going to learn HL. That's it. Okay? Now, what